Geometry Unit 1, Lesson 8, Rotations. So in this lesson, we want to look at rotations, and we're going to talk about angles and line segments. We're going to rotate them, and we'll have to use a ruler and a protractor and even a compass to measure distances. And then we'll look at coordinate rules for certain standard rotations and also learn to specify rotation angles. So in this particular diagram, a rotation has been shown, and we're going to look at some of the properties of that. To do that, we're going to connect P with each of the pre-image and image points. So here is A, and I'm going to connect that with P. And here is its image, A prime, and I'm going to connect that with P. And then we'll do the same for B and B prime. So we'll go from B to B to B to P, and then B prime to P. And then we'll do the same for C and C prime, although that one's harder to see. Here, I'll just draw it. It should be done with a ruler, but we should have that. Now, if we look at the angles, we'll see that the red one, which is the BP, B prime, is a right angle. The one from A to A prime is also a right angle, and then the one for C to C prime, even though you can't see it very well, is also a right angle. So each of the angles are the same. In this case, they're 90 degrees. And then if we look at the distances from AP to A prime, which we can measure with our compass, we can stretch that out to A, and we'll see that that's exactly the same as the one to A prime. So if we measure that, the one from A to A prime is the one is A to B prime. It will be the same from here, from B to P. If we go from B to P, whatever distance that is, when we measure it, it's the same here. So this one is the same as this one. And then the same is true for C. So the two segments, whatever they are that match, will have the same length. So in general, these are the properties of any rotation. If we go from an image point to what's called the center of rotation, from the pre-image point to the center of rotation here, that angle, if we look at any one for each of the vertices, all of those angles will be the same. They won't always be 90 degrees, but there will be some common angle that goes from every image point to the center of rotation, from every pre-image point to the center of rotation to the image point. And then also these distances will be maintained. So the distance from A to P will be the same as from A prime to P to P. B to P will be the same as B prime to P, and so on. So now let's look at how can we draw that, and we'll just explain this by actually doing an example. We know that all of the angles have to be the same, so we're going to use our protractor to draw the angles. I'm going to start with B here at the bottom, and I'm going to go from B to P, and then it says we want a clockwise rotation of 120. So in order to do a clockwise rotation, if I line this up here, and I have to have P at my center, and I put this on the 0, if I go this way 120, that would be clockwise. If I'd wanted counterclockwise, which is this way, I would have to now line it up this way, and then I would go 120 this way. So make sure you're going in the right direction. It will be either clockwise or counterclockwise. This one says clockwise rotation, which is as the clock goes. So I'm going to go here and measure 120. So from here, this is the 0 scale. The 120 is on the outside. And of course, make sure that it looks, this 120 is an obtuse angle. So we know that B prime will have to be somewhere along this line. And then we also know that the distances are preserved. So we'll just go ahead and measure the distance from P to B. And then we have to have that the same as from P to B prime. So we're going to take that and then swing it over here where that meets. That is now the point B prime. And we have to do that for each vertex. So we're now going to go from P to A and then do a 120 angle. We'll now do our 120, again making sure that it goes in the counterclockwise direction. Again, it's harder to do with colored pencils. Best if you have a nice sharp pencil in order to get your angles right. So we're now going to go from A until we get to the 120, which is about here. And these won't be perfect when you're doing them by hand, but they should be close. And then we need to measure again this length. So from P to A, that's a little bit longer than it was from P to B. So let me hold that up so I can do it better. And then so now that you've measured that distance, you're going to take and swing on the other side to this one, and that will be now where A prime is. And finally, we need to do that for C. B and C were on the same line, so I don't really need another angle. All I really need here is the length. If that were in a different line, then I would have to do another line from P to C and do another 120 angle. So I've measured from P to C. I mark that here, which I don't know if I maybe have moved. Let me double check that again. I think I moved. There, that was up here. That is now C prime, and then you would connect those. And when you're done, it should look like the same triangle, but rotated into by a 120 degree angles. These two are on the same line, just like they were here. And then B to C. And that should look like the same triangle, only now it has been rotated 120 degrees clockwise around that point. Now we could do this for any angle, but just like we had for reflections, when we had certain lines that we wanted to reflect around, if we have rotations and we have certain multiples of 90, then there are rules, coordinate rules for those. And these are a little bit harder to remember, but the way I do it is the first one, which is, we'll always assume, by the way, counterclockwise unless it says otherwise. 90 degrees counterclockwise, you switch the order of these and you change the sign of the second one. So or the new one, you'll change the sign of the first one. So you switch the order and then you change the sign of the one in the new position. And then go to the 180, you're going to start from this one, and you're going to say, okay, I'm going to switch the order and change the sign of the one that will now be the first one. And then 270, you're going to start from the 181, switch the order and change the sign of that one. And then 360 takes us back to where we started, so there is no change at all. I'll also tell you that at 90 degrees counterclockwise, this is the same as 270 degrees clockwise. And this is the same as 90 degrees clockwise. So if you're given the clockwise one, it will have the same rule as the 90 degrees counterclockwise, and so on. So one way is to memorize them, which is what we're going to do here, or to get those and simply remember what those are. So this particular one asks us for 270 degrees counterclockwise, which is this. So we're going to switch the order and go here. Or I'll show you another way where we could simply do it. We know that 270 degrees clockwise is 90 degrees clockwise. So you can take an arm, which I call an arm. I'm going to go from the origin. I'm going to do one horizontal and one vertical. I could go this way. It really doesn't matter. And now I want to swing that 90 degrees. So because I'm going to do 90 degrees this is clockwise. So yes, I now want to go 90 degrees clockwise. Counterclockwise would go this way. It will take me to the same place, so I could rotate it that way, but I'll do it in a shorter distance. This was 3 long and 1 down, so I'm going to go 3 long and 1 down. That will be where A prime is. This is now along here is 7 across and 4 down, so I would go 7 down this way and 4 this way. That would be B prime. D is 1 and 5, so instead I would go 1 this way and 5 this way. That will be now D prime. And C was 5 across and 7 down, so I would go 5 this way and 7 across this way. That would be C prime. And then we could connect those, and that should be our new figure. I'm going to make sure that those are true also by these coordinate rules. So if we switch the order, we know that the image A prime, we're going to switch the order and then change the sign of the x one, so that would be -1, -3, and if we check, that's where -1, -3 went. If we do b prime, again, we're going to switch the order and change the sign of this one, so b prime should be -4, -7, which we had. The coordinates for c were 5, -7. So when we get c prime, we're going to get -7, -5, where we change the sign of that one. And if we check, that's -7, -5. And then if we get d, d was originally at 1, -5. And then if we take and use the coordinate rule for that, this -5 will become first, this one will become second, and we'll change the sign, and that's -5, -1. So we could have used the arms to get the points and then gotten the image coordinates, or we can use the rule and get the coordinates directly. You may do whichever one of those you prefer, either through the rules directly, but you should be able to get these coordinates, or you can rotate the figure yourself by using an arm to figure out where it goes, or any other method that may work for you. Some people can see those rotations easily and some people can't. Again, I went 90 degrees clockwise, but that's the same as going 270 degrees counterclockwise. And now the last thing we want to do is we want to be able to find an angle of rotation, so I'm just going to explain that through the example. It says find the angle and the direction of rotation around the point P. So in order to do that, we have to pick one of the image and pre-image points. This says from A to P and A prime to P. We could do B and B prime. So I probably showed you A and A prime are the answer. That's probably what I have. So I'm going to do B and B prime instead. So I'm going to draw one from here and then also one from B prime to P. And we know that those have to be the same angle for any points. Then you're simply going to measure that angle. So I'm going to see what the measure of that angle is, make sure that my 0 line is lined up there. And I will find that this is 65, 66, 67. So it's a 67 degrees. And then I have to decide which direction I went. Well, I went from B to B prime. So that was in this direction. And that is in a clockwise. So this is a 76 degrees clockwise rotation around the point P.